Hi everyone, in this video we're going to talk about common type of source. In electronic circuit we have DC source and AC source. What does DC and AC mean? DC means direct current and AC means alternating current. That's the definition of DC and AC, but sometimes we also use DC or AC to describe a voltage source. So what exactly the difference in the circuit? We can first put a load into a DC circuit. When we put the battery on, the current flow from this direction. If we plug the output voltage, we can see the waveform looks like this. In a period of time, the output voltage is a constant, but when the time goes on, the battery will run out of energy, so the waveform might look like this. All the way slow go down like this. It will only stop here. It won't go across the line. That means the current only flow in this direction. It cannot flow from this direction back to the battery. However, in AC circuit, if we plug a load onto an AC source, if we name this side as positive, this side as negative, then our current sometimes flow in positive way and sometimes flow back. If we plot the output voltage, we will see our output voltage act like this. Sometimes it's positive and sometimes it's negative. Although I plot a sinusoid wave here, but AC source is not always looks like this. It can look like this, or it can look like this. In ELEC 2103, we know that we can use sine function to describe sinusoid waveform. So for this waveform, we can use sine function to describe our output voltage. So this is our peak voltage, and our voltage can describe as Vm times sine omega t plus phi. This Vm, we call it amplitude, and the omega represents the angular frequency. The relationship between omega and the period is t equals to 2 pi on omega, or the relationship between frequency and omega is 2 pi f equals to omega. And this phi is the phase angle. Our output voltage not always start from 0. Sometimes it might be start here, and sometimes it start from here. The shift descent from left and right, we call it phase shift. We are not always have sinusoid AC source. Sometimes we can have AC source looks like this or this. Then how do we analyze those kind of source? So now I'm going to introduce the way to analyze non-sinusoidal source. To analyze non-sinusoidal source, we need to use Fourier transform. I think you guys learned this in ELAC 2302. Now I just did a quick review. Let's look at this with non-sinusoid periodic signal. As we know, this non-sinusoid signal is combined by 5 sine wave. So we plot this sine wave here. The first sine wave is when omega is 50. So this is when our omega equals to 50. Plot looks like this. The second one is when our omega equals to 150. That means our period is shorter and our frequency is higher. It might look like this. And also our amplitude here is 2. The first waveform, the amplitude is 10. And the third one is when our omega is 250. It means our frequency is much more higher. It might not look like this, but I'm just showing that it can be higher frequency and our amplitude is still 2. I'll just leave 351 and the 10K one here. For this plot, if we look from this side, we call it time domain. But if we look from this side, it transforms to frequency domain. So what exactly we're looking at our frequency domain? Let's plot it out. In our frequency domain, what we are looking at, the x-axis turns to be our frequency. It's omega. Here's omega. And our decomposed waveform shrink into one line. So for our first waveform, it becomes to a line. And the amplitude is 10. This is our first sine wave. And our second sine wave is when omega equals 150. The amplitude is 2. And the third one is when our omega is 250, amplitude is 2. Third one is when it's 350, amplitude is 2. The third one is when our omega is 10K and the amplitude is 0.2. This is our 5 decomposed sine wave. However, as I talked here, we need amplitude, angular frequency, and phase angle to describe a sine wave. But now we only have amplitude and frequency. We need to define the phase angle in those decomposed sine waves. This example, we all have sine waves start from 0, but in the real world, those sine wave might not always start from 0. Sometimes it can start from here. And the phase shift here is our phase angle. We need another axis to represent phase. Sometimes the phase can be positive. So I see the phase can be positive, but sometimes the phase can be 0. It's exactly our example here. And sometimes the phase can be negative. The transform between time domain and frequency domain, we call it Fourier transform. The Fourier series formula is Vt equals to V0 plus or the decomposed sine wave. To sum up this video, we first talk about the difference between AC source and DC source. The biggest difference between AC source and DC source is the polarity. If the polarity doesn't change, it's a DC source. If the polarity changes, it's an AC source. And then we talk about how to use sine function to describe a sinusoid AC source. And then for non-sinusoid source, we use Fourier transform to analyze it. That's all about today's video. Thank you for your watching. We will see you in next video.